All right, so looking at the first one here, looking at a positive force. You talked about this yesterday. A positive force is a push, and we always like to kind of throw it up there that it's a kind of a giving, okay, a giving force, So if you are giving, you are pushing what you're repelling. So which occurs between those charges? Yes, and I agree with you that it is a like. Those charges are a like charge. Okay, I'm going to go ahead and just kind of clean this up here for you. So those are like charges. Excellent. Now looking on the other hand, looking at a negative force is a pull. So if a negative force is pulling, it's kind of being selfish, or what we can say is taking. Either one of those is absolutely good if you, what way you want to think about it. So a taking or being selfish, okay. So, and it is pulling, that means it attracts, which occurs between what kind of charges? Yes, I do agree with you. It occurs between the charges. Excellent. So those two, we need to make sure that we have those in mind as we look through our lesson today. So what traits do you look for in a friend? Someone who can match my vibe and give off good energy. I like it. Absolutely. That is an excellent one there, Regine. Loyalty, because God knows how many fake friends I've had in my life. So yeah, Isaiah, again, it's one of those things. Loyalty is a huge one. If you in a friend, I agree with you on that one. Loyalty, good crack humor. Yeah, so good humor. Yeah, good humor. Absolutely. yeah, I totally did think so. Good humor, absolutely, Elisa. Honesty, reality. If you're still trying to figure out what kind of friends is a true friend to you, it takes some time to kind of know yourself before you can really kind of figure out which friend is a true friend. And that's okay. This is the age to do that. But remember that a true friend is somebody that is honest, that values you for who you are. And if your friends are not doing that, then it's time to maybe look for some newer friends that do value you for who you are and are honest and who are loyal to you and are just all around good to you. Someone you will let know. Perfect. I see somebody writing right now. So just kind of remember that as we go through life, that friends will come and go, but those true friends that are, or those traits that you're putting up there will stick with you forever. Okay? Alrighty. So when someone I know when doing bad, well, yeah. Someone will let you know, and it's kind of sometimes that tough love where they will let you know even though you don't want to hear it, but they're out there because they care about you. Absolutely. All right, so let's go ahead and look at our class Connect session, is always recorded and distributed for learning purposes. Please do not share any personal information into the chat box for your protection and protection of others. Be respectful and always, always, always participate. Yep, that's so true. That's important as well. Yep, absolutely. I agree with you there, Bowen. All right, let's go ahead and look at this schedule here. OMG. Look at this, week 11 of our 13 weeks. That means we have 2 weeks left. Looking at this flying by super fast. I think we have 12 to 13 days. We don't know. All we know is coming down to single digit, people. So get your stuff in if you haven't done that. So make sure that you are getting all your unit projects in. I've seen a couple flying up in mine. We will be getting those Unit 4 projects graded fairly quickly. If you have other unit projects, don't worry. Those are going to be graded as we are grading along, so they may take a little longer than they did before. So with that, just kind of, oh my goodness gracious, look at that. Mrs. Larkin just kind of refreshed this, 11 days. That's even worse than 12. Oh, I cannot believe it. Coming down to single digits makes me sad, but kind of like, wow, I can't believe we've gotten through this. There we go. It is the middle of the week at Wednesday, October 28th. We're going to talk about electric currents. We're going to be doing our 5 CD assignments. So you're going to continue the same assignment that you did yesterday. So if you haven't done so, go ahead and start pulling it up. If I haven't said it, that's all right. Start pulling it up. And we're going to be also doing our 5D attendance discussion. Folks, please remember that attendance discussion, to get full attendance discussion, you need to wait till the end of class and you need to answer the question completely. Don't just give us random stuff, because we'll just kick it right back to you. So make sure you're answering the question completely. If you're here, get the full attendance credit. It's not that hard. All right, here we go. So today we're going to be talking about calculating electric force between two charges using Coulomb's law, and we're going to be demonstrating this through our 5CD assignment. That means the same one that we did yesterday, we're going to continue that one today. We're going to get an 80% or higher. If you accidentally turned it in, go ahead and start the second attempt. If you have redid it and kind of maxed out all of your attempts, let us know. We can reset your attempts for you. All right, so with that being said, I want you to go ahead and open up your assignment. It's popped up into the chat box there. I'm going to go ahead and I will throw it up into the, if I can, I'll throw it up into the, on the slide here. So no excuses here, folks. Make sure you get your notes or assignment opened up. There you go. There, I'm going to try to put it in the middle, find it somewhere, probably put it right there. There you go. So you have it in the chat box, you have it up on the board. You can also find it in the grades tab, so it shouldn't be that hard. I'm going to give you about 20 seconds to pull it up. Give us a green checks when you have all that pulled up. Again, it shouldn't be that hard. You did it yesterday, so it should be right there. So green checks when you got that pulled up. Go, go, go. And look at this, looking for green checks from Alex, green check. Looking for green checks from Haley, Isaiah, green checks, please. Kalia, green check. Monique, green check. We do not want to move anybody into the check-in room. Again, we have 25 of us, 22 green checks, so Alex, green check.
All right, we know what to do here. We did this one yesterday. Go ahead on the whiteboard, tell me what are these two charges. Again, pay attention to if there are less lines. Oops, that's the wrong color. If there are less lines, here we go. Less lines means that it is smaller or weaker charge, right? Remember, the lines are the electric force field representation. Right, so if you have less of those, then it's a smaller or weaker force field. If you have more lines, then that's going to be larger and stronger. And remember that if the lines go in, that's like someone who's selfish or taking. And if the lines go out, that is someone who is giving. So that should help you remember which one is positive, which one is negative. Looking good. All right, there we go. Getting lots of answers up on the board. Let's see who we have participating. I see Alyssa on the board. I see Regine working. I see Sally working. Want to see some names that we don't always see. I see Antoine on the board. Let's get some more participators on the board. I see Lisa working. Let's see here. Who don't I see yet? I haven't seen participation yet from Alec. I see Jaylyn on the board. Have not yet seen Andres on the board or Angelo. I see Isaiah now, perfect. I see Stephen on the board, Haley working, thank you. Want to see some of those less frequent names. Thank you, Rowan, up on the board. Great job, everybody. Perfect. Let's go ahead and take a look here. So awesome. I'm going to go ahead, pause these tools. These look great. So yes, on the left side, we have less lines. Less lines means it's going to be a small charge or a weak charge, and we know that the lines go out, and lines going out is like a giving person, and so that makes it a positive charge. So great job, everybody. Let me go ahead and highlight this one. This one is a small positive, and over on the right we have more lines. More lines means more electric force, and so this one is going to be a large charge or a strong charge, and the lines also go out, again like a giving person. That makes them positive. We've been talking about positive and negative traits in ourselves, positive and negative traits in our friends. There we go. So a large positive. Great job. Down here, we can see that for this one, the lines also go out. This one has more lines, right? This making it a large charge. The lines also go out, again, like a giving person, making it positive. So you are absolutely correct. The one on the left is going to be a large positive. Let's take a look at this one, large positive. And then the one on the right is a little bit different. This one has less lines, making it small or weaker, and the lines go in. Lines go in, like a selfish person, and selfish people, we talked about how that is something that is usually negative. So this is going to be negative. This is a small negative. Great job. Go ahead and give me a rainbow, everybody, if you feel comfortable with this. Even if you didn't participate going over the review, go ahead and give me a rainbow if you're beginning to feel comfortable with that. Looking good. All right, let's go ahead and move on. So we talked about Coulomb's law yesterday, and Coulomb's law is how you can actually calculate the electric force that we've been drawing, right? So we've been taking a look at diagrams. Now we know how to actually calculate that. We talked about how F stands for force and is measured in newtons. K is Coulomb's constant, which is 9 times 10 to the ninth. That's just a number that you need to know, 9 times 10 to the ninth. And Q1 is the first charge measured in coulombs. Q2 is the second charge, also measured in coulombs. And R is the radius or distance. Remember, in this instance, these are synonyms to each other. So radius or distance between the charges, which is measured in meters. We already discussed this at the start of class, that if you get a positive answer, that means that you have a giving force, which is a push. And we know that if we have a positive force, a push, that must be occurring between like charges. So 2 positives or 2 negatives. A negative force, on the other hand, is going to be a taking force. And if you have a taking force, that means it's trying to take the charge closer to it. It's trying to attract it, pull it. And that happens between opposite charges. Opposite charges, which means a positive and a negative. So we should feel pretty comfortable with that so far. I also want to review scientific notation in case anyone wasn't here yesterday, because in our problems we have very large numbers and very small numbers, and we don't want to have to write them out every single time. And so that's what we're going to explain right here. So scientific notation uses this idea of times 10 to the exponent, and if that exponent is positive, that makes a really big number, and if the exponent is negative, that makes an itty bitty tiny number. So let's go ahead and take a look at an example here. 9 times 10 to the ninth, which is Coulomb's constant. Please make sure that at this point you commit that to memory. So this is Coulomb's constant, at least for the duration of this lesson, because we're going to ask you about it several times in this lesson. 9 times 10 to the ninth is not the same as saying 9 times 1 billion. So if you put 10 to the ninth into a calculator, it would be the same as saying 9 times 1 billion, which would be 9 billion. 9 billion. The way that we can easily convert these is just by moving the decimal. So if the decimal started after the 9 and it's a positive exponent, in this case a positive 9, that means we need to move the decimal in the positive direction, which means the big direction. So I'm going to move this to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I get the same answer. This is 9 billion. So here's what's actually happening, and then here's the trick to make it easier to do. Okay, same thing with at the bottom. If you were to take a very small number like -4 times 10 to the -5th coulombs, you can go ahead and go the opposite direction to make it smaller. So again, if you were to plug into a calculator 10 to the -5th, you would get a very small number that you see right here. And then when you multiply that together, you get a very small number. Again, our trick is if your decimal starts after the number 4, and you have a negative exponent, that means that you move in the negative or smaller direction that many times. So here I'm going to move in the negative direction 5 times. 1, 2, 3, 4, 5 to get 0.00004 coulombs. This is all review from yesterday. Go ahead and give me a birthday cake if you remember this from yesterday. Again, scientific notation is an easy way to represent really big and really small numbers. Beautiful. All right, now on a calculator, it's even easier to do this because on a calculator, instead of writing out times 10 to the, so instead of writing the times 10 part, you can actually just replace that with the capital E. Capital E, not a lowercase e. So capital E, we could just say 9E9, which would represent 9 times 10 to the ninth, or -4E, -5, which would represent -4 times 10 to the -5th. So again, when you put Coulomb's constant in to the calculator, you can just write 9E9. Easy peasy, easy peasy. Remember, some calculators do use capital EXP or lowercase exp. All of those count, so that stands for exponent of 10. The only exception is please do not use the lowercase e button. Lowercase e button is an actual different number, and so that will not help you. So lowercase e, don't use that. Either use EXP or capital E. Capital E. Looking good. All right, let's go ahead and do our first practice problem for today. We already did questions 1, 2, and 3. 3 was a practice problem yesterday, so now we're going to go ahead and do number 4 and practice number 4 together. Taking a look here, positive charge is 3 times 10 to the negative fourth coulombs, and another positive charge of 5 times 10 to the negative fourth coulombs are separated by 2 meters. What is the force between them? Let's go ahead and take a look here. So 3 times 10 to the negative fourth. Let's go ahead and label this. What would I label this as? Go ahead and tell me in the chat box. What would I label this as? Is this K, Q1, Q2, or R? Remember, there are 2 charges, so which variable do you have 2 of? There are 2 charges, so which variable do you have 2 of? Awesome. Yep, this is going to be Q1. Q1. C is not an option. There is no C in our equation. There's no C in our equation. All right, go ahead and tell me 5 times 10 to the negative fourth. What's that one going to be? 5 times 10 to the negative fourth, what would that variable be? Perfect. Yep, this one is going to be our other charge, so this one will be Q2. Beautiful. And then 2 meters. 2 meters is going to be what? Go ahead and tell me in the chat box. 2 meters is a distance, and in this case, the distance is represented by what? Sorry, by. You don't have to put the squared part. Just the letter. Only give me the letter. Yeah, this is going to be just r, right? So this is just the r, or the radius slash distance. Beautiful. All right, let's go ahead and begin to plug things in. So again, what number do I plug in for Coulomb's constant? What number do I plug in for K, which is Coulomb's constant? It's always the same number. That's why we call it a constant. Make sure you put it in calculator form. I wrote it in the chat box if you scroll up a little bit. What's our magic number for today? Awesome. I see Rowan in the chat box. I see Antoine typing, Daniel typing. Sally, thank you. Yeah, we're going to go ahead and plug in Coulomb's constant, which is 9E9. Again, this is our Coulomb's constant, or 9 times 10 to the ninth, also written as 9E9. And let's go ahead and multiply it by our first charge. How would I write my first charge in calculator form? How would I write my first charge? 3 times 10 to the negative fourth in calculator form. Again, replace that times 10 to the with what? What do we replace that with? I see Sally, I see Rowan, I see Isaiah, I see Alyssa and Antoine, Regine, thank you. Yes, this will be 3e negative fourth, which is the same as saying 3 times 10 to the negative fourth. And last charge, let's make sure we get some participations from some quieter people. Angelo and let's see here. Brisa, haven't heard from you in a while. Darius, Greta, Haley in the chat box. I see Ivana working. Jasmine, want to hear from you. Luis. Eventually, everybody, you do need to be able to do this on your final exam, so that's why we're practicing it so much right now. You do need to be able to use your calculator on your exam. Otherwise, your life is going to be really difficult. Yeah, make sure you're using capital E, though. Remember, it must be capitalized on your calculator, so 5e negative 4. Good. All over r squared. Our r in this case was 2, so 2 squared will go on the bottom. Go ahead and begin plugging in the top into your calculator. All right, I'm going to go ahead and take a quick picture of this and then show you how I plug it into mine as well. So let me go ahead and drop this for us up on the whiteboard. All right, so we have 9 times 10 to the ninth, which is 9 exp 9, times 3 times 10 to the negative fourth, 3 exp negative 4, times 5 times 10 to the negative fourth. So 5 exp negative 4. Remember that for Google Calculator, I highly recommend just Google the word calculator. This is the easiest calculator to work with. The negative sign and the minus sign are the same thing, which is why it's so easy. Go ahead and get this done and tell me, what answer are you getting? What answer are you getting? Yeah, we don't make you remember any of the equations. We'll give you the equations. You just need to understand how to use the equations. So you don't need to memorize equations. Awesome. Yeah, we would not make you memorize all these crazy equations. Even when I was in college and taking college exams, they would give us equation sheets. You can't see the board. Why do I do this every single time? Okay, let me go ahead and try that again. Thank you, Antoine, for telling me. Otherwise, I would just not know that for a really long time. All right, there we go. So 99 times 3e to the negative fourth times 5e to the negative fourth. Go ahead and get that up there. I see answers from Lisa. I see Jasmine. I see Alyssa, Antoine, Regine, Sally. What are we getting? Make sure you're participating. Oh, you could see it on the board. Okay, phew. All right, good. All right, let me go ahead and jump back over here. We're going to press enter, and yes, we should be getting 1,350. Great job, Brisa. Great job, Isaiah and Daniel. So on the top, 1,350. 350. On the bottom, 2 squared is the same as saying 2 twice, so 2 times 2. And what is 2 times 2? What goes on the bottom? What goes on the bottom in our denominator? Vocabulary, the bottom of a fraction is the denominator. Thank you, Lisa. This is easy mental math. What is 2 times 2? Thank you, Alyssa. Thank you, Antoine. Thank you, Jasmine. There you go. Yep, 4 goes on the bottom. And now let's go ahead and divide the top by the bottom. Remember, anytime you have a fraction, that's also the same as division. This is literally a division sign. And so you can go ahead and do the top number divided by the bottom. 1,350 divided by 4. What do you get? Awesome. Yes, there we go. Don't forget your units. Stephen, double check your numbers there. Okay, gotcha. Yeah, you just missed it, typed it. Good. You should be getting 337.5 newtons. Great job. Taking a look here, everybody. Our answer, is our force positive or negative? Is our answer for our force positive or negative? Go ahead and tell me in the chat box. Take a look at our answer right here. Yeah, I mean, obviously it doesn't have a negative sign, so it's going to be a positive answer. So this was positive. Positive is like a giving force, so will that be a push or a pull? This is a giving force. Is that a push or a pull? Yeah, it's going to be a push, right? It's not taking it, it's trying to give the charge away, so it's pushing the charge away. And so if you're pushing charges away, does that mean the charges attract or repel? If that force is giving and pushing away, is that an attraction or repelling? Attract or repel? Yep, they repel. What's another way I could have known that they repel? What's another way that I could have known that they repel? Besides just looking at my answer, here, how else could I have known that they repel? Analyze the actual question. Also know this because, yeah, exactly. They're both positive. They're both like charges. They're like charges, and we know that like charges repel. So actually, you didn't even need to do the calculation to know, right, exactly what kind of force you would get. You would know that they repel. You would know that they push away. A push is like a giving force, and so you would know that this was a positive force. Great job, everyone. Let's go ahead and keep on moving.
Of a negative 1.5 times 10 to the negative 5th coulombs. So what is this variable? What is this going to be the variable for? What is this variable? Who lets me know? Chat box. Perfect. Yes. Yes. Perfect. It would be my Q1. Excellent. So looking at the next one at 2.5 times 10 to the negative 5th. Looking at this, what would this be my variable for? Q2, excellent. Lisa's got an answer. Sally, excellent. Region A, beautiful. Jasmine, excellent. You guys are awesome. Man, you're on it today. Here we go, Q2. And then looking over here, are separated by 0.3 meters. So meters is a distance, and what is it going to be represented in my equation? Good. Sally's got an answer. Excellent. Good. Jasmine, excellent. Yes, good. It is going to be for my radius. Remember, the radius is going to be for my distance. So let's go ahead and plug in my numbers. So what is, in calculator form, what is my coulombs constant is our magic number for today. We're going to be having this magic number all throughout this unit here. So what is my constant? Remember, use calculator form. You can tell me in the chat box. I see Elisa working. I see Antoine. I see Stephen. Excellent. Excellent. Yeah, it's going to be 9, capital E. Don't forget, it's going to be capital E to the 9. And then obviously we're going to multiply it. We're going to multiply it by what? What are we going to multiply it by? Region A's got it up in the chat box there. She was just jumping a little bit ahead, but that's all right. Yeah, good. Region A's got it up there, and again, I do need to see what is my Q1, what number am I going to use. Sally's got it up in the chat box, beautiful. Looking at Angelo's working, Antoine's working, beautiful. Yeah, I have a negative 1.5 capital E, using calculator form, capital E to the negative 5th. Excellent. Yeah, looking at my Q2, what would be my Q2? Good, yeah, perfect, perfect. I got region A's up on the board. I just want to make sure Good. Isaiah's up on the board. Sally's up on the board. Beautiful. 2.5. Capital E. Remember, we're going to use calculator form to the negative fifth. Excellent. And then we're going to take our distance, our radius, okay, and we're going to use it 0.3, and we're going to raise it to the second power, so 0.3 squared. All right, so let's go ahead and I'm going to flip my screen real fast, show you how to do this on the calculator just in case you forgot. Here we go. So looking at this, I'm going to go ahead and plug in my constant, 9, exponent to the ninth, times a negative, and you're going to go ahead and use that subtraction sign, 1.5. Don't forget to get that point in there because that will be giving me a completely different number. E to the negative fifth times 2.52.5 exponent times to the negative fifth. Here we go. And then what answer do I get? Who can tell me in the chat box? Perfect. Sally's got an answer. Make sure you try it on your own calculator. Make sure you try it on your own calculator so you know how to do it. You feel good at doing this because you will be doing this in your final. Excellent. I agree with everybody. Here we go. So I do get a nice negative 3.375, and obviously 0.3 squared, what do I get? 0.3 squared, it's going to be simply 0.3 times 0.3. You can go ahead and let me know in the chat box. Yep, that's all it is. It's literally taking this and going 0.3 times 0.3. That's what squaring is. What do I get? Good. Lisa's got an answer. Sally's got an answer. Lisa's got an answer. Beautiful. Antoine's got an answer. That's right, Antoine. Be confident with your answer. You got it. Isaiah, Jasmine. Excellent. Yeah, it's 0.09. Now we take this number of negative 3.375 and we divide 0.09. What do I get? You don't want any naked numbers here in school. Nasty. Nasty. Oh, yeah. So gross. Yeah, it's good. We get 37.5 newtons. Absolutely excellent job. Excellent. Yep. So now, obviously, looking at this, we can actually figure out the force. And looking at the force, do I have a positive or a negative force? Positive or negative force? Good. I have a negative force. Good, Lisa. Good, Antoine. Good, Isaiah. I see them all working. So if I have a negative force, is that going to be a push or pull? Is that going to be a push or a pull? Again, negative force being selfish. Yeah. Good. Absolutely. It's going to be a pull, which means that my charge is going to attract or repel. Yes. I did because I saw you working, Antoine. Yeah, they're going to attract. Now, I'm going to go ahead and refer back to the original problem because I didn't have to do any of this, but I did need to do it to practice because we need to make sure that we are proving ourselves. But looking at these two.
Perfect. Okay, so for this last one, we are going to, this is our last practice before you need to do your application problem. So make sure you're following along. That way you feel really comfortable with this before you do your application problem. Please note that for this question, the exponents are written as to the negative fourth in your assignment, but they are actually meant to be to the negative 6. And so the answer key is still correct. The answer that we get while we do this problem will still be correct in your assignment. All right, let's go ahead and talk about this. A negative charge of negative 2 times 10 to the negative 6 coulombs and a negative charge of negative 8 times 10 to the negative 6 coulombs are separated by 0.04 meters. What is the force between them? Taking a look here, what is my first charge labeled as? What is the variable for my first charge that I'll eventually plug it in as? Perfect, Lisa. Perfect, Sally. Yes, this will be my Q1. And what about my second charge? How do I label my second charge? How do I annotate that? My second charge will be Q2, beautiful. And last but not least, how do I annotate my distance here? Don't include the squared, just tell me what the variable is. Yep, this one is going to be my R for the radius or distance, distance. Plugging it in, what number do I plug in for Coulomb's constant? Again, this right here, K is Coulomb's constant. What number do we plug in there in calculator form to make our lives easier? Awesome. I see Lisa. I see Sally. Yep, 9 times 10 to the ninth can also be written as 9e9 times my first charge. How do I write my first charge as a calculator, as I would in the calculator? Using scientific notation. Yes, Louise. Yes, Isaiah. Awesome. I see Lisa in the chat box. Perfect, Andres. Negative 2 times 10 to the negative 6, perfect, can also be written as 2e negative 6. So 2e negative 6 times my last charge. How would I write out my last charge? Everybody, how do I write out my last charge? Negative 8 times 10 to the negative 6. Perfect. I see Lisa. I see Isaiah, awesome. I see Sally working. Yep, negative 8e negative 6. Great. On the bottom, I'm going to go ahead and put my radius, which was 0.04 squared. It does get squared eventually. Let's go ahead and calculate the top. Please go ahead and calculate the top. I'm going to go ahead and take a screenshot and work on it with you. Let's go ahead and do this one together. All right, sharing this with you up on the board. There we go. All right, so on the top we have 9 times 10 to the ninth times, sorry, this should be negative 2. Negative 2 times 10 to the negative 6. All right, times negative 8. Again, this is your negative sign as well, negative 8 times 10 to the negative 6. Remember this capital E or this EXP stands for times 10 to the. What do we get on the top? I see Regine, I see Sally working, I see Lisa, I see Antoine typing, Greta and Isaiah typing. What do we get when we multiply these together? Let's get some more participation from Alec and Angelo. Want to hear from Darius and Greta and Ivana. Oh, thank you, Greta. I see yours now. I see Alyssa and Stephen working. Want to hear from Madison and Keon and Jasmine and Jaylyn. What do we get when we multiply all these together? Make sure you can use your calculator. You will need to use it on the final exam, and we're not going to give you answers on the final exam, so you need to be able to do it yourself. Cool. All right. So yes, pressing enter, that's going to give us 0.144. Excellent. And on the bottom, go ahead and tell me, what do you get when you do 0.144 on the top? What do you get when you do 0.04 squared, which is the same as saying 0.04? Times 0.04. Remember, squared means that you do the number twice. Go ahead and tell me in the chat box. Perfect. I see Rowan, I see Regine, Lisa, Antoine, Isaiah. Yes, 0.0016. Make sure you get all those zeros when you now plug this in. Please divide the top by the bottom. Top number divided by the bottom, and what do you get? Regine, I think you might have typed something in incorrectly, so try that one more time. All right, awesome. Getting lots of correct answers in the chat box. Yes, you should get 90, and it will be 90 newtons. Great job. Again, this is still the correct answer, even though the exponents were written wrong in the assignment. This is still the correct answer in the answer key. Go ahead and give me a green check when you have number 5 saved. I need green checks from everybody. Otherwise, we will go ahead and move you to the check-in room. You have 30 seconds. Ready, get set, go. 10 seconds remaining. Green checks, everybody. All right, waiting on Alec. Waiting on Ivana, Jalen B, and Keon. Thank you. Waiting on Keon and Ivana. All right, let's just go ahead and really quickly review. Our answer here ended up being what? If we had two negatives and you multiply two negatives together, what kind of force do you end up with? Correct. Two negatives multiplied together actually gives you a positive force. Positive means like a giving force, and if you have a giving force, does that end up being a push or a pull? Does that end up being a push or a pull? Perfect. This is a push, and so those charges will do what? Those charges will do what? They will repel, absolutely. And how else could I know this? I also know this because, how else do I know this? Excellent. They are both negative. They are both like charges because they are like charges. So like charges, you could also do this in reverse. You could know like charges means they'll repel, means they're going to push on each other. Pushing is like a giving force, which would make it positive. Either way you want to think about it, that works. That works. All right, let's go ahead and keep on moving here.
Set this force equation up for this scenario, looking at a positive charge of 6.0 times 10 to the negative 3 coulombs and a negative charge of negative 9.0 times 10 to the negative 3 coulombs are separated by 200 meters. So looking at this first one here, I'm just going to go ahead and help you set this up. But again, we're going to know how to complete this or how to figure out this problem but just by looking at these numbers. Looking at this first problem here, what is the variable for this particular charge going to be? And I forget, that your chat box is off, so I'm just going to go ahead and tell you here. We've already figured this out. It's going to be our Q1, right? Looking at this next variable of a negative 9 times 10 to the negative third, this is going to be our second chart, or our second Q2. Q2. And then obviously when we look at 200 meters, we know that it was dealing with a distance, so it's going to be our R. So with that being said, we're going to go ahead and just set this up. Actually, I'm going to turn on your chat box. I think it's important that you know how to do this. Tell me in calculator form what is the K, which is my Coulomb's constant. What is my Coulomb's constant? Go ahead and let me know. Good, good, good. 9, capital. Good. Make sure our E is capital. That's important because then it would be a completely different number. 9 to capital E, 9. Going across, what is going to be my Q1? What is my number for Q1? Good. Excellent. Excellent. Yeah, it's going to be 6, capital E to the negative 3. And then going again all the way across to my Q2. What would be my Q2? What would be my Q2 in calculator form? Good. Stephen's got it. Sally's got it. Rowan's got it. Perfect. Yeah, it's going to be negative 9, capital E, negative 3. Excellent. Then coming down to my R, what would my R be? What would my R be? Yeah, it's going to be 200. And remember, we're going to square that. So we're going to raise it to the second power. Now, I just set this up, but we know by just looking at, and I'm going to go ahead and shut our chat box off because this is where our answers come in. We know by just looking at these two numbers, is my answer going to be positive, negative? Without doing the math, is my answer going to be positive or negative? And if it is, which is it going to be? Is it going to be a push or a pull? Remember those negative forces are taking, those positive forces are giving, which means the charges will attract or repel. Will they attract or repel? This is for number 6. This is the last question in your assignment. This is one to try on your own. We will be here to kind of guide you and help you, but this one is to try on your own. So let's go ahead and I will give you, 25 seconds to work on this. 25 seconds. Go, go, go.
Excellent. Yeah, let us know how you did today. And then for your attendance today, we have a positive electric force. Remember, positive means that it is a giving force. A giving force or a pushing force, giving or a pushing or a repelling force. What kind of force, that occurs between what types of charges? That occurs between what types of charges? Like charges or opposite charges? Go ahead and tell me in the chat box which charges does that happen between, like charges or opposite charges, in which we have a positive, giving, pushing, repelling force. Awesome. Yes, I see lots of people in the chat box have the correct answer. So this is going to be happening between like charges, like charges. Great job, everybody. That's the answer for your attendance today. Thank you so much, and I will see you later. You have 60 seconds to get that done, and then we are going to go ahead and log people out. Bye, everybody. Have a wonderful day. We'll see you back live on Friday. Recording stop.